Welcome to part 2 of Shave 2 Weeks off your next project schedule using WebORB Data Management. And while you're doing that, how am I going to do this? I'm going to create a new project from scratch. So a new Flex project. I will call it Food and Drinks Client 3, just in case I've got others laying around. That looks like a good place to put it in that path. The application server type is ASP.NET. I'll click Next. Yes, that's the right path for these things. I will validate the configuration. Okay, that's good. Everything else looks good. We'll go to Next. I like my main applications to be named main just for consistency's sake. Let's see, I also need to add a SWIC here. This is the WebORB SWIC. It's in the current installation of WebORB for .NET, WebORB Assets WDM for WebORB Data Management. And this implements or has the implementation of access to the runtime messaging engine for client synchronization purposes. That's the main reason why we need to include that. So we add that, and with that, I'm pretty sure we can finish.
Hey Jim, this is Mark Filler here.
Yep.
If I could quickly inject the zip file that WebORB Management Console provides. Also, in the client folder, there's also lib folder that includes the SWIC. So one can either import it the way you did it, or just bring it over from the generated zip file.
Right.
Double click
Which
client.
would of course be for some reason. Let's get that's right in here, and there it is. All right. Go back to my client, grab those folders, drop it in at the top level. All right. Now I'm going to make this my main. The default application. All right, now there's one other thing you need to do here that gets a little, that's easy to forget to do, and if you forget to do it, you're going to get all sorts of weird errors, and that is to add a minus services path, and that path is, let me find this here, I'm going to go back to, actually I'm going to do this the easy way and cheat, which is to open up a application that I wrote last night, which I know has this path name in it, and copy and paste it out of there because I'm lazy. And one should never do in real-time demonstrations anything that is a source of error if one can possibly avoid it. So I'm going to paste that same path into the compiler directives here, and this defines the various channels and destinations and other such things that are described in WebORB's documentation that you'll need, that WebORB needs in order to find its, to configure itself. All right, so that's there, and I'll look at the server and make sure that it's generated correctly. Okay, that path is correct. All of those things look correct. All right, so we should, fingers crossed, be able to compile and run this application at this point. Oh, darn. All right, let's check my errors. 47 errors. The base class active record was not found. That's because the FAD client is screwed up.
Make sure that the WebORB.SWIC is placed into the libs folder.
And that is in fact the problem, that that's empty. I will. Yep. All right, it is building. It is gone. All right, let's try this again. All right, Mark, looks like that was it. Excellent. Thank you for that. So here we have the test drive application for that database. It's not necessarily pretty, but it's surprisingly functional. There's a different page for each table, each class in the database. The product screen has the most data already in it. There's only one account defined. There's no orders or order lines, but there are many products. And this application demonstrates full CRUD. I can, for example, go in here to the strawberries item. I don't know if you can see this clearly on the webinar screen, and I'm going to change the cost of strawberries from 20 to 18, and that has been, I can then press the save button, which updates the database accordingly. Or I can add new items, I can remove items. Also notice up here I can change the page size. In this particular example, I have so few data items that it's not relevant. There's only 5 records. But if you're bringing in large amounts of data, WebORB can handle the data paging for you. You just set an argument and everything else is done for you. So I'm not going to spend a lot of time in this application. I will show how to use the functionality that it exposes in the next sample. So let me check my notes to make sure I've shown everything I need to show here. 1 page per table, full CRUD. You've got create, update, read, delete, everything's there. Data paging. I can also show client synchronization, but I'm going to save that for the next application. So let's look at FlexBuilder and look at the client-side code that we generated for this. So you can see that the same classes have been created here. We've got an account class, an order class, order line, 1 per table, and data mappers for each of those as well. We also have a data mapper registry and food and drinks classes, which do a fair amount of work. Most of the rest of these are essentially placeholders to allow you to override the code as necessary with your own business logic beyond the simple object relational mapping. So pretty simple. That's about it for that. Now, although the code you've seen is quite simple, there's a fair amount of it, and it's boring to write, and it's really quite error-prone. So it is better for it to be generated by WebORB than to have specialists writing the code, because it's a waste of a specialist's time. And as we know, time is money, so let's look at how much money has been saved by generating this code rather than writing it yourselves. We'll do that by looking at the Data Management tab again and clicking on the Calculate Return on Investment button. That brings up the Save Development Cost dialog that shows that you can save a considerable amount of money even on a simple database by using WebORB Data Management. Now, this calculation is based on the number of lines of code created, estimates of how efficient a developer is, and the cost of that labor in producing this code. So you can change those around to get numbers that you like better, but the bottom line is using WebORB Data Management can save you time, and time is money. And of course, the code you haven't seen is the code that's in the WebORB runtime, which is where most of the magic happens anyway, with client synchronization, transactions, data paging, and so on. So let's see how to implement simple CRUD operations, the create, read, update, delete, within a WebORB application. And to do that, I will close this application, or this project rather, and open this one called Simple CRUD. Let's look at the source code for that. Actually, let's run it first. It's always nice to see what the application does before you dive into the code. So it has a data grid that displays all of the products in the products table. So we've got grapes and lettuce and oranges and so on. I can hit the create button to create a new product. It's going to randomly fill its variables because there's no other user interface for creating that here. If there's changed data, then I can update it, and I can also find all, which just hits the database again and brings back all of the product data. So first, let's create a new one. There's a new product called Foo0, and its price is randomly set to 4 units. Create another one. That's Foo1, random price, and so on. I can then go through and delete these. So let's look at the code for the create and delete operations. I'll kill that application, walk into the main.mxml. It's a very short and simple application. All right, so here's the source code. On creation complete, when the application gets started, it calls active records product find all. So using the active record pattern, it returns all products and puts the result in search result. Now what is actually returned is an empty array collection. That's what's returned synchronously. Asynchronously, when the query returns the data, that search result is populated, and anything bound to it, because search result is defined to be bindable, any user interface elements that are bound to it are updated. And that's also the function we call when we hit the find all button, right? Exactly the same functionality. Now, when we press the create button, we create a new product, implement, or rather initialize its name and price to randomly determined values. I have to set the picture file name to a irrelevant name or else the creation won't succeed. I'm not showing any pictures, so it doesn't matter what I do there. And then I simply create the product and thus add it to the database. That's all there is to it. Create an object, initialize the object, create the object within the database. So I'm not dealing with table-oriented data there, I'm dealing with object-oriented data. And likewise, on delete, I find the selected item in the product grid, cast it to product, and call the remove function. That's all there is to deleting that entry from the table. So let's go back to the application, which is not there. I already killed it. So I need to run that again and show you the next buttons. So here we've got, I've hit the database again, and foo0 and foo1 are still in the database. I'm going to go in here and change the price of foo0 to 5. Now I've changed that value, and so the update button is enabled. I'm going to change another value, and it is also updated. But notice if I hit find all, I'm going to pull back all the data from the database, and those numbers have changed because when I change them here in the data grid, they are not automatically updated in the database. Okay, to do that, I need to hit the update button. That runs some code so that when I then find all, I'm getting back the changed value. So the update button committed those changes. So let's look at how it did that by going back into the code and looking at the code for the on update button. What update does is it actually implements a unit of work so that I can do these updates as a single transaction. Now that's overkill for this particular example. I just wanted to show the unit of work and transaction processing built into WebORB by using a transaction for this update. So we create a unit of work object for each product in search result. We see if it's dirty, that is if its values have been changed, and if so, add it to the unit of work. Then when we've added all of the dirty products to the unit of work, we simply commit the unit of work. And that's all there is to it. Now, in production code, you'd have a lot of error handling code here to find out whether or not the commit succeeded and to tell the user, if not, why not, and what to do next. This is intended to be as simple a bit of code as possible, so it doesn't do any of that error handling. There's one other method to call here, and that's read to just update. It's very simple. I'm going to look at the selected item and get its price and find all of the items that have that same price. So let's just look at the application again, over here, and I will find all of the items that have a price of 5, right? Because that's the price of the currently selected item. So hit the read button, and there they all are. Right? Instead, I'll bring in all of the data. This time, I'll find all of the products that have a price of 12, and of course, there's only the one. All right, so that's how reading data works. Again, it's just a couple of lines of code. So that's it for the basic, simple CRUD. And thus endeth part 2 of 3. More video after the jump.